Okay. All right. So the topic today that we want to discuss is what are the different steps that one can take to make a strong career in data engineering, right? Cloud data engineering. Let me add this word here. Cloud data engineering. Okay. Now, okay, I can see everybody. All right, great. Now, before I even get started, what questions do you think you would have that I must address in today's session? You have attended, you've joined the session, so I'm sure you have certain set of questions in your mind. What questions would you have that that I must cover in today's session? Please tell me. Any questions that comes to your mind about this career, cloud data engineering? What do they do? What is it? Anything that comes to your career? Anybody? Puneet, Anumitro, Pujatri, Pratik, Avanish. Any questions that comes to your mind about data engineering? All right, since okay, good question. How do we upgrade from being a data analyst to a data engineer? Very good, and that also means that that I must cover what is the difference between a data science or a data analyst and data engineers. Okay, so we will talk about that as well. Very good question. Anything else? All right, no. If nothing else, let's get started. My name is Pratik Agarwal. I'm going to be the instructor for today's session, guys. I've spent around 17 years in the data industry with various different clients. Started my career in the US after my master's in the US, and since then I've consulted a variety of different clients, both in India, in Europe, US, some clients in Australia as well. I have realized, I've seen this industry changing in front of my eyes from being just a decision science industry to now having a very clearly defined classifications between data science and then data engineering. And within that also, there are multiple classes that we have now. We are aware of data analytics person, business analyst person, MIS person, or a deep learning person, right? Multiple models, multiple roles that have come within all these verticals. Within a data engineer as well, somebody who's like a big data analyst or a big data engineer, then somebody is a cloud data engineer. So a lot of different profiles that have come in front of my eyes. So we'll talk about many of these things as well. I hope you all can hear me loud and clear. Okay, yeah, all right. Okay, so in Ivy, of course, we've been working with large number of companies, large clients, helping them build their data strategy, helping them implement their data strategy, helping them build solid skill sets, ramping their internal team, getting converted into center of excellences in the data world, including data science and data engineering. And we've been doing it for the last 14 years. We would have more than 25,500 alumni base. We are present in 6 different cities in India. But we worked with wide variety of companies, and the thing that we have observed is that in the last, especially in recent years, we are observing that we are working with CXO level folks as well as we are working with fresh college grads. So everybody is trying to learn something or the other in the world of data, and we are specialists in the world of data science and data engineering. So that's what we have been doing for so many years. Now, let's talk about what is data engineering, and how can one make a career in data engineering, and then we will take some of the recommended steps that I would strongly recommend anybody who's willing to make a career in data engineering. So the first thing is, what does a data engineer do, right? What does he or she do exactly in the world of data? So I picked up some information from Glassdoor, from Medium. Of course, I also have my own experiences, but I just wanted to make sure that the world also sees the way that I see it. So I'm just going to explain using some of the information that I saw in Glassdoor. You can also find it very easily. Glassdoor says that who data engineers are. Data engineers are mainly those people who help in transforming data into a format that can be easily analyzed. So the main difference between a data engineer and a data science person is data science person is a consumer of data, consumes data, right? And data engineer ensures that the data is ready to be analyzed. That means he is the provider of the data infrastructure or keeper of data infrastructure that would help the data science person to be able to consume or access the data so that that data science team can analyze it. So the basic difference between a data engineer and a data science team is that data engineering team is the team which will help the organization build the entire technology stack, entire data technology stack or required to support real-time, almost real-time access to the data in a format, in a structured format, so that the data science team can easily analyze them. So this is the first statement, which is very important to understand, that data science people analyze the data, help businesses make decisions. Data engineering team will make sure that the entire infrastructure is ready for any data science person to analyze the data quickly, right? They do this by developing, maintaining, and testing infrastructure for data generation. Okay, and we will look into a typical architecture of or typical pipeline of data engineering in any large organization. Okay, and then that probably will have that probably will result into a lot of questions in your mind. A data pipeline. Now, what is a data pipeline? I picked it up from Medium. One of the authors' description was given. His name is Satish Chandra. He says that data engineering has 5 stages in it. Okay, or 5 stages which can be grouped into 3 heads: data engineering, analytics or machine learning, which is where your data science comes into the picture, and delivery or presentation. These 2 things are taken care by the data science team, right? Because these two activities would result into consuming the data in order to make or present the decisions which will affect the businesses progress and so forth. And the data engineering team will ensure that the collection, ingestion, preparation of data is done properly. If you notice here, 50% of effort goes into data engineering side and 50% of effort goes over here in the analytics, machine learning, and the delivery or the presentation of data side. Okay, so both the teams are equally important. Let me tell you that. Right now, I think we have understood what data science team does, which is which uses the data that is residing in the data infrastructure to make decisions. A simplest example of that would be that, let's say I will go to a database, download some data, and put it into a Power BI or Python software, and then we will try and make some head and tail. We'll try and predict what may happen in the future. But I'm, as a data science person, I'm not really so much concerned as to how that data was stored in the database, who cleaned it up, who ensured that everything is correct and everything's correctly stored in the database or in the data warehouse. I'm not so concerned about that. I'm more concerned about running or creating reports or running an analytical model or building machine learning model in order to predict what may happen in the future, which will directly influence the decision. As a data engineer, I am worried about a lot of other things. I am worried about collection. How are we going to collect the data? What are different sources from where we can collect the data? Ingestion. That means once we have collected the data from different sources, how would that data flow internally into the data warehouse or into data lake? Preparation, cleaning the data, ensuring the data is ready, ensuring the data is coming without any quality errors from different sources. Computation. Now, this computation and presentation is taken care by whom? Who takes care of computation and presentation now, guys? Who would take care of computation and presentation? Computation and presentation would be taken care by The data science people or the data engineering people? So these collection, yeah, go ahead, Pratik. Go ahead, Pratik.
Yeah, data science.
The data science. So these two activities are taken care by the computation, or the analytics part, or the machine learning part is taken care by the data science team, whereas collection, ingestion, and preparation of the data is taken care by the data engineering team. Okay, so if you see, the opportunities are immense in both the areas. Data engineering is great for people who are a little more technology savvy, a little more inclined to work behind the scene, and they're comfortable to work with multiple cloud tools, multiple software tools. They not necessarily need to be computer programmers, software programmers per se, because most of the time for these data engineering stuff, we end up using a lot of softwares which are already pre-created, right? You do have to do a little bit of coding, but that coding is not to build a lot of data structure algorithm, but to be able to use variety of different software tools, especially on cloud. So we'll talk about it. Let's look at what is the meaning of collection. Let's go deeper into each one of these phases: collection, ingestion, and preparation, so that we know, what exactly they do. So I'm going to go to the next sheet, next page, and I'm using this Satish Chandra's medium block architecture. If you notice here in collection, we get the data from mobile apps. We can get the data from mobile apps. For example, you're using a software on your mobile. For example, you're using, let's say, Swiggy's app on your phone, right? Then there may be some people who are using Swiggy's app on website, right? And by the way, Swiggy's app may be integrated with, let's say, Amazon Pay, or let's say Amazon's website, whereby you go to Amazon's app and you are saying that through Amazon you're ordering food through Swiggy. So it is connected to another portal, and that data integration is happening through something called as microservices. And then IoT. Imagine Swiggy decides that, what, we all have refrigerators at home, and imagine 5 years down the line, all the refrigerators have a screen. So it is a screen, and all the refrigerators are connected to some kind of a Wi-Fi internet backbone, a Wi-Fi internet network. Now Swiggy says, what, we now have a refrigerator app, right? So your refrigerator, which is an internet enabled device, or internet on cloud, or IoT, as we say, Internet of Things device, that means any appliance which is connected to the internet, right, is now also going to have an app on Swiggy, or app for Swiggy, and through your refrigerator's app, you are just pinching your order on Swiggy, or maybe you're ordering some instant delivery from Swiggy's Instamart, which is the new service that they launched, from within refrigerator. So that also is a data entry point. So you see, the data sources can be pretty extensive, can be social media as well, can be your mobile phones, your websites, your different integrated web apps, or your appliances as well, right? So the data could come from multiple different sources. Ingestion essentially means to ensure that the data goes from data sources to something called as a data lake. Now, what is a data lake? Data lake is your typical big data infrastructure, where the data that is coming is of wide variety. Could be unstructured data, for example, images, videos, text data, let's say Twitter sentiment data, or can be structured data as well. For example, transactions that we make, any order that you place, right? So it could be wide variety of data that could come in large volume, right, into from these sources, and then it would be ingested or taken into a pipeline and sent to company's data lake, which is essentially nothing but a large Hadoop ecosystem generally, which is the Hadoop is the ecosystem platform which is generally used for managing large variety, I mean, basically managing big data, right? So it goes into a data lake. Now, in that data lake, it could have multiple, again, multiple set of tools. If, let's say, you're working in a stock trading organization, which does algorithmic trading, so they need real-time access to the data. Then on top of Hadoop, you may also have a Spark-based cluster management system. Spark is again one of the open source system which works on top of Hadoop, which will help you manage real time or help you manage or process real-time data, real-time data processing. For example, the data is getting generated in the source. Say, for example, stocks are being transacted every day, right? So the data is getting generated in different sources, and in the real time, we are transforming or computing or calculating or making changes or making decisions based on real-time data access or using Spark. Okay, as the Hadoop doesn't allow you real-time data access. It does something called as a batch processing. Anyway, if you would have any more questions on that part, I can talk about more later. But essentially what we are doing is that the data sources come using collection, gets ingested into data lake, and from that data lake, we start preparing it. These three parts are handled by data engineers, right? Preparing meaning ensuring that there are no quality errors, ensuring that the data that is coming is now properly structured and put into company's data warehouse, because from there, the analytics team or the data science team can then start their EDA, can they start their analysis, EDA meaning exploratory data analysis, can run machine learning algorithms, and so on and so forth, or create visualization using Power BI or Tableau, right? So all those things can then be done by the data science team as part of their computation and presentation task. Got it? So these are some of the basic fundamental things that a data engineer does. Now, why did I say that cloud is very important? All these things, whether it is about collecting the data from multiple sources, whether it is about forming data lakes, having a Hadoop infrastructure installed somewhere, or a Spark cluster management software unified ecosystem installed somewhere, all these things will then be installed on a cloud infrastructure, right? Maybe on Amazon's AWS, Google Cloud Platform, or Microsoft Azure. These are the three very, very popular cloud platforms which are out there, right? Most of the companies these days do not end up installing these softwares locally on their premise machines. They do it on the cloud, because when they do it on the cloud, then it becomes scalable. It becomes easier to manage. It becomes cost effective. The reason why it becomes cost effective is that when you are creating on-premise infrastructure, meaning the traditional way of having large machines, large hardware on the premise of an organization, and then installing all these big data softwares and application management systems, there the problem was that what if you have unused spaces? That unused spaces, you still have to pay for it, because you bought large infrastructure. But when you are on cloud, you only pay for what you are using. So if today you have more requirement, you pay for more. If tomorrow you have lesser requirement, you pay for lesser things, right? So it becomes extremely cost effective that way, right? And you do not have the headache of managing all these hardware. Then it can be easily managed by a cloud service provider like AWS, GCP, or Microsoft Azure. So that is the advantage of working with cloud. And all the cloud service provider have very strong integration with all these different softwares that we are talking about, right? So that is why being a data engineer who understands how to work on cloud infrastructure becomes an extremely important capability to have in today's time. So that is why we call this role as a cloud data engineer role. Right? All right. So this was my first initial introduction to what data engineers are supposed to do and how do they differentiate. How is this role different from data science role? At this point of time, I will take questions. Any question that you guys have, I'll be more than happy to answer. Anybody? Anomitro, Pratik, Pujatri, Puneet, Sabyasachi, anybody? Any questions?
Hello, sir.
Yes, sir.
This is Anomitro speaking. Okay, sir. I'm just asking that if there is a cloud and everything is controlled by that, so in our practice set, when we're just practicing in our home, so how do you utilize that? Like, how do you practice in?
Very good question, Anumitro. And in today's time, what has happened is, what has happened now is that sorry, I don't know why it's not opening. Let me open. Okay. So what happens, Anumitro, is that in today's time, you have Amazon Web Services or AWS Web Services free tier, right? So for the first year, for the first whole year, it is free. So most of the tasks that you want to do, you can do it for free for first year. Similarly,
Okay.
GCP free tier. Google Cloud Platform has free tier. Then Azure, Microsoft Azure free tier.
Okay.
Do you understand what I'm trying to say? All the
Okay.
three major softwares, a major cloud service provider, have first tier as free.
Okay. Okay.
I get a point. So if you are a student who wants to learn on any of these things, the best thing is that we create a free account.
Okay.
Okay. Now,
And control by that.
Sorry.
And control by that.
Yeah.
On the free.
And you create all these things, and you start using them. As simple as that.
Okay. Okay.
See, I'll show you. I mean, I'll probably give you a sneak peek view into cloud. For example, yesterday I did one workshop on how do we work with Google Cloud Platform. How do we run SQL queries, the relational database on relational database management systems, which are hosted on Google Cloud Platform. And I did everything for free. Okay. So say, for example, this is an interface to Google Cloud Platform, and I'm using something called as Google BigQuery Platform, which allows me to run SQL queries on the databases which are hosted on Google Cloud Platform on cloud. Okay. So if you notice here, and the best part is that it can work with terabytes of data very smoothly. Okay.
Okay.
For example, for example, there is a famous public data set available, public database available on public data set available on names. Okay. Not coming. Let's say there is a database called as USA names, which is publicly available on Google Cloud Platform, BigQuery platform. And there is so this is a database name, and these are the two tables. And this table, suppose if I open this table just to see what is there. So there is a column called a state, gender, year, name, number, right?
Yes.
Now I want to find, let's say this is the preview of this table. What it shows is in which state of the US, gender, year, what name, how many names were registered for a particular name, how many people, how many kids had registered, how many parents had registered, let's say LC as a name in Arkansas for female in 1910. So 6 people had, right? Now, and 482 people had registered as name for Annie in 1910 in this particular Alabama in the US, right? So let's say if I want to run a SQL query, I click on query and I go to editor, and here it says select star or select from BigQuery. That is the name of this project.
Yes, yes.
Dot. This is the name of the data set or the database. Dot. This is the name of the table. And if I write, if you notice, right, I want to find the top 5 popular names in 1910, only in 1910 or in the year of 1910, in whole of US. Okay, the top 5 names in 1910 in whole of US. So where year is equal to 1910, just looking at this integer, okay. So year is equal to 1910, group by, not group by, sorry. Yeah, all right, let me group it by.
Yes, group by year.
Yeah, group by year. And then year, comma, count of star as total occurrences, right? And
Yes.
then order by count of star, right? And then limited by 5 and order by this, sorry, group by name. Why am I doing group by name, not here? Because we want to find those names which are the top 5 names in year 1998.
Okay.
Yeah, order by this and DSC.
Okay.
Semicolon. So now, if you notice on the right hand side, it says this query will process how many MB of data? 84 MB of data, right?
Yes.
Now, if you work with data, right? If you have if you have hosted data in local machines, right, like in your laptop or your desktop, even to host a database of 10 MB or even to host one table of 10 MB, it is going to take significant. I mean, to host and query a table of 10 MB also will take considerable amount of time. But here we are going to process this query on 84 MB of data, and that is going to take, suppose if I select this and run it, that takes 3 seconds, less than 3 seconds, and we got the result.
Okay.
And then you can see that these are those names which were the most common names in 1910. Top 5 occurring names in 1910. Is it making sense?
Yes, yes.
Yeah. So here, what I wanted to show you was the advantage of creating a cloud infrastructure is that you're not limited by the space, by the processing power of a local machine, right?
Okay. Okay.
Second, you are not limited by a place. You can work from anywhere, right? So what we just did here is what a data science person or a data analytics person will do, right? But they will only be able to run this kind of a query and do this analysis that we just did if they have if they have a platform like this, right, whereby they can host huge data, terabytes of data. They can process terabyte of data very quickly as well, and then they can present, explore data. I can take this data into Google's Data Studio, which is like Tableau and Power BI, and then I can present the data online. I mean, on cloud. Do you understand what I'm trying to say? So the idea of doing so is that when you do something like this on cloud, then you're not restricted by the hardware, by the processing power of a local machine.
Yes, yes.
And hence, the cloud data engineers who ensure that this kind of infrastructure is up and running all the time without any problem, and that the data access that we have done over here is error free, is the role of the data engineer. And just to give you a sneak peek view on how cloud console would look like in AWS. So if I go to AWS, I already have an account there, and so you see that in AWS, okay, it's just taking a little bit of time. Yeah. This. So I've logged into my AWS account, and if you notice here, in AWS, these are the services that I'm working with. But if I click on all the services, so if you notice, it has services for computation, for machine learning. This computation, right? Now, if you compare with the steps, this computation. Do you see this, guys?
Yes.
So computation, for all kind of computation, right? You would have things available here. For all kind of machine learning, which the data science people use, you would also have everything available here. Plus containers, storage. These are the things that a data engineer really needs to know very, very well. That how container is like a virtual OS where you can install any kind of application. For example, if you want to install Excel, I give an example of Excel on a container on cloud. Container meaning small OS where you can install any kind of application very well, very easily, right? So, and why is it called elastic? That means you can increase the size of that container. Meaning, if you want to install Excel onto it, and you want to install MS Access also, PowerPoint also onto it, and you will then be able to do all those things. Is it making sense? Yeah. And storage, if you want to store anything on cloud, so that would be part of storage here. And the databases, again, if you want to host any database on the cloud, then that would be part of databases here. This also a cloud data engineer needs to know pretty well. Migration, at times you want to migrate from one cloud platform to another, maybe from AWS to Google Cloud Platform and something like that. So that's when you would use something like this here. Networking, security, these are taken care by different teams. As a cloud data engineer, not so much concerned, but yes, you do interact with these teams as well quite frequently. And yeah, so those are the most important things that you do. A little bit of IoT maybe, but those are the most, yeah, video services like Kinesis video stream for real-time data access. That would be very, very important as well. Okay. Yeah, so idea is that any cloud service provider would have similar services available to help you do any of these tasks that we have spoken about. Yeah. Okay, great. Now let's talk about, so any other question from here? Any other question? Any other question?
Sir, I am having one question.
Yes, sir.
This is Shubhusha.
Yeah. Tell me.
Sir, so basically data engineering and cloud engineering, the cloud architect, both are same or
no, they're different. A cloud architect may just say that, all right, I mean, so let's talk about this. So the cloud architect would know a little bit about everything here, Sabyasachi. Okay? And cloud architect would also know, for example, here, a cloud architect would also know how to migrate the data properly, how to migrate not just the data, but applications as well as security settings, as well as all those things. Cloud architect would also know about networking, about security, identity and compliance, would know all these things. more than he would know about databases per se, he would know about storages per se. Do you understand, Sabyasachi? So cloud architect is somebody who knows a little bit about everything, and cloud architect would work very closely with the cloud data engineer as well, or the vice versa. I mean, cloud data engineer will work with cloud architect also. The cloud architect is not a specialist in data lakes. He's not a specialist in Apache Spark. He's not a specialist in working with Hadoop infrastructure, right? He doesn't know how to work with, let's say, data warehouse that much in detail, like how a cloud data engineer would do. I get about cloud. So if you want to compare with real world, consider a cloud architect as somebody who is handling the office's entire IT infrastructure, Sabyasachi. Do you understand what I'm trying to say? That person is handling the IT infrastructure. That means he knows how to install server, he knows how to install networking equipment, how should they work together. But within server, what are the things that we can do as a data engineer? He would not know.
So,
Okay.
is it
so
essential?
Cloud architect, yeah. Go ahead.
So, for a data engineer, is it essential to have a certificate like AWS, things like that? If one wants to join in data science in the real world scenario.
I personally strongly recommend. In fact, Ivy's program as well. Ivy's program also. I mean, the entire data engineering course that we have, the cloud data engineering course that we have, is actually aligned to. You have an option to choose AWS, which we recommend because there's more demand, or you can also choose the the Google Cloud Platform certificate as well. But I strongly recommend that you should try and get the international certificate as well. Yes, you do have to work a little harder for it. Yes, there is a little extra money that you may have to pay, but that we strongly recommend. I personally also, as a professional, I would strongly recommend that you try and get AWS certified big data specialty or a professional data engineering certificate from AWS or Google Cloud Platform. I would strongly recommend. So either you can go for a Google Cloud
Sir, your voice is breaking.
Data engineer, or you can go for. Oh, is my voice breaking, guys?
Yes.
Can you guys hear me now, loud and clear, everybody?
Yes.
Okay, good. So what I was trying to tell you was that to answer that question, whether you should go for international certification or not, as I said, I strongly recommend. Our course also, we have aligned it to international certification. So you have an option to choose the AWS, which we recommend as well, AWS certified big data specialty, or professional data engineer certificate. One of the two you should target, definitely.
So this certification will get after the this course. This
certification you will get after this course by appearing for these examinations.
Okay.
The certificate that you will get once you have. So none of the certificate, even Ivy's certificate or that NASSCOM certificate that you get as part of this program, I don't know why it's not mentioned here. The NASSCOM certificate or the Government of India certificate also you get, but that too you get only once you score 70% or more in each of the modules that is covered in this program. Okay. Plus, for these international tool specific or cloud specific certificate, you do have to appear for their examination.
Okay.
Anumatro. I get a point.
Okay.
Now, what are the skills in terms of tools that somebody like a cloud data engineer, like any cloud data engineer should know? SQL, as I said, is extremely important, guys. Okay, whether you are working as a data engineer or a data science person, SQL is extremely important, very, very important. Right? I mean, AWS is again Amazon Web Services. It is big data technologies, you know, those things that I was showing in Amazon's console. Essentially, things which will allow you to work with big data, which will allow you to access large amount of data on real-time basis. Those are the things that, you know, are going to be important. And in terms of the tools, Hadoop, Spark, Kafka, right? Hadoop is required because Hadoop allows you to work with big data, large volume of data very, very easily. Spark is built on top of Hadoop, right? What Hadoop does is that it takes big data and divides into small parts. Like, you know, it takes like a, let's say, imagine 1 terabyte of a file, right? A video, you know, very, very long video. It will divide into, you know, let's say 100 MB of files, and will divide them into different nodes and clusters. And then those files is processed in each nodes on parallel. Whereas Spark, so Hadoop is very good in batch processing, whereas Spark, which is built on Hadoop, on top of Hadoop, relies on something called as in-memory processing. In-memory processing. This is better for real-time access of data. Real-time access. But any in-memory application has a disadvantage that it can only hold that much of data, as much of RAM that you have in your system. Okay. If you have a very large RAM, which is costly, by the way, RAM requires a lot of money, much more money than your typical SATA hard drive or even solid state hard drive would require. In-memory processing requires a lot of RAM, so that is why it is costlier. But then the advantage is that you get real-time access to the data. So as a data science person, I would say, yes, I want real-time access. But as a data engineer, then I would say that, yes, you can get real-time access, but it will cost you more. You understand? So Hadoop, how does Hadoop work? How does Spark work on top of Hadoop? How does Kafka work? SQL and NoSQL. NoSQL is not just SQL, very, very important when you are working with non-structured data, unstructured data, for example, as text files, videos, images. So then unstructured databases like MongoDB and all that becomes very, very important. Postgre and Cassandra are structured databases, but for unstructured database like MongoDB and all, you need to know SQL as well. And then for pipeline management and workflow management, how the ingestion should happen, how the entire workflow will happen, you need to know Azkaban, Airflow, very, very important. You know, I mean, we just finished one project, large project with one of the data engineering companies, where we trained some of their experienced staff on working with only this part, only these two parts, in fact, very smoothly. So that was one of the most important task of that particular project, right? So that could also be a very large project. An experience with cloud services, for example, EC2, relation database services, and so on and so forth. Experience with stream processing systems. Stream is Spark streaming. Streaming is, let's say there are a lot of, let's say there is a famous cricket match going on. A lot of people are talking about that cricket match on Twitter, and so that data should be should be accessible in real time. And let's say there is a famous cricket match going on Hotstar, right? And Hotstar wants to live stream that cricket match to millions of users. So that is again would be done using Spark streaming. So yeah, I mean that becomes very, very important as well, to know how can we access real time data as well. And I would say Python. If you know Python very well, you can work with a lot of things. Python and also Scala, by the way. Scala is the native language in Spark system. So a lot of things, you know, data processing, data manipulation can be done using Scala. A lot of automation can be done using Scala on top of Spark. Okay, so these are the things which a cloud data engineer should know. All of them have a different role to play, right? And if you look at our program details, IV's program details, so that's how we have designed this program as well. So the job description that I was showing you was from Glassdoor, and this is a program that we have designed in consultation with Amazon's, one of the senior cloud data engineers, Amazon's and Google's senior cloud data engineers. So big data, of course, we introduce you to some of the concepts which are important here to understand. Hadoop infrastructure, although more than Hadoop these days, people use Spark, but Spark is built on top of Hadoop. So that is why you need to know a little bit of Hadoop as well. And then tools which are built up on top of Hadoop, which will help you to work with large amount of data. And then Hive. Hive is the query processing. It's like SQL, very similar to SQL, but works on Hadoop data file system. Okay, so very similar things that we do as what we do in typical SQL. And then Scala, which is the function programming language supported by Spark, right? Which allows you, which is like any other programming language, but essentially designed to work on Spark. So then you actually learn Spark ecosystem, general purpose clustering computing framework. Spark is getting very popular because it is extremely lightning fast. It's much faster than typical batch processing that is done in Hadoop. Although it works on top of Hadoop, but the only thing that it uses from Hadoop is the Hadoop storage system. So it works on top of Hadoop, and then it is extremely popular these days. So that is why it is one of the larger modules in our program. And then we further go into APIs within Spark, which allows you to connect Spark with multiple services like Python or any other, external services that it has to work with. Then optimization. Now, this is a little advanced topic whereby how can you optimize your Spark clusters? How can you minimize the hardware requirement, cloud requirement, and so on and so forth? And streaming, as we saw, we were talking about streaming the job description, that Spark streaming. So this is what it is here. So real-time processing of data, and how do you do that? And, what are the things that happen there? And every module essentially has certain project activities. And then you also work on a final project, where you will end up using everything, right from the beginning till the end. You end up doing everything from here. Okay. So that is the overall course module as well. So, as you can see, it's pretty much aligned with the job description that is required. Another question that people have is, what is the amount of salary that one can expect from, from a cloud data engineer, or what kind of a salary that a cloud data engineer can expect? So let me open Glassdoor for it. Let me just Google, okay, for you, cloud data engineer salary, and it'll open a Glassdoor link. We're looking at, of course, we want to look at India, but overall in the world, if you notice in the US specifically, it's a very high confidence job role. That means this data is based on large number of fresh recent salary reports. That means a lot of recruitment is happening in this world. This is the average salary in the US, $116,000 per year, which results into approximately $1 crore a year. But in India, the typical cloud engineer would get, starting with 6 to 8 lakhs, all the way to 21 lakhs with a couple of years of experience. And the full career path. Yeah, so average base pay, base pay only, not even incentive. Base pay for a cloud data engineer is around this much, and the median pay is around 7 lakhs, right? Average years experience 0 to 1 year, this much, 2 to 4 years, 73%. So yeah, so that's what it is about, and you'll get a lot more information as well here. But and the salary trajectory increases quite. Yes, please, question. Anumitro, you had a question.
Yes, sir, I just want to ask one thing. For me, I'm working professional, and I'm working in a single company from beginning. Okay, so I'm working
single company
from the beginning, like 2016. I'm working on a single company. I'm not changed that company for last 5 years. So I'm working on that. So now my question is, I'm working in a different field, like in automation coding in hot dogs. Like this is based on word automation, something like that. That needs coding, but that is different from this data engineering. So like when I'm switching, when I'm transforming in this data engineering field, so should I consider like a fresher, or should I consider like a experienced, like this kind of?
To answer that question, what I always say is that would the let's say in two scenarios, Anumitra, without asking you for your CTC. Let's say if your CTC in X role right now, let's say with I'm assuming 5 years of experience is, let's say, I'm just taking an example. Let's say 7 lakh per year. Okay. Now, in a cloud data engineer position, the median pay package is more than 7 lakh. Do you understand, Anumitra, what I'm trying to say?
Yes.
So what happens is that if you are getting into the cloud data engineering kind of a role, then the growth is very, very high. And money is typically not a problem in this industry. Because just that, there is huge amount of openings that is there.
Yes.
Do you understand? So the designation doesn't matter whether you are considered to be a associate cloud data engineer, which is like an entry level cloud engineer, or you're considered as a senior data engineer. It doesn't really matter, because the salary would probably be more than many other roles, even with few years of experience.
Okay. Okay.
Okay. Any other question, guys, on this?
I'm having one question.
Sure. Please go ahead.
Your voice is not audible. Hello.
Can you guys hear me?
Yeah. No, it's okay. Sir, I'm coming from totally different background. Okay. I'm working right now in non-IT domain. Okay. In assistant manager in a supply chain company, and I want to make a transition. Okay.
Then, Sabyasachi, I would not recommend you to start eyeing data engineering position from the beginning. I would then say that, IB has very strong courses on data science and data analytics. Explore that world, Sabyasachi. Unless you're very, very passionate about this cloud technologies. Do you understand? Although I have seen people from commerce background, from English background also getting into data engineering space, but they just have to work significantly harder. I would rather, in your case, I would rather say that, maybe follow the data science. Any other question?
Sir, in this data engineering field, how much coding is required? Like how much coding knowledge is actually required for? Like,
well, see, let me put it like this: you are not going to sit and write a lot of codes, Anumitra, but you're going to use a lot of these tools to do things, Anumitra. Okay, so you got to understand how SQL Server works, how data works. Python, yes, you're doing a lot of things, but the coding is not very difficult, because all the things are done using packages and API services. Okay, so it's not like you're writing millions of lines of code. Okay, so as long as you understand what variables are, what are the basic data structures, you would be fine. And because a lot of things are done using packages and libraries.
Okay.
But you got to be a good problem solver, because you're working with such large data, and the data comes from so many different. Something or the other will keep breaking.
Sir, your voice is breaking.
So you have to keep. Sorry. So what I was trying to tell you was, something or the other keep breaking, and you got to be a good problem. All right. What else, guys? Now, one of the last thing that I want to talk about was, which I strongly recommend for any kind of such role, is how do you make a good, strong career here? You know, so although I would just change this, some things I should have changed it. You got to know SQL, you got to know a little bit of Python, definitely. You got to learn cloud technologies like the ones that we spoke about today, right? And work on projects, definitely work on projects, because most of the data engineering questions that you will face in the interview will be situation specific. Situation specific. Let's say the situation is, let's say we have 10 million Twitter tweets or Twitter posts, and we want to bring it into our data lake, and then we want to do sentiment analysis. What are the challenges would you face? What process would you follow? So, you know, a lot of scenario specific question. What if this API stops working? What would you do? How would you ensure that it is working again? A lot of scenario specific. So that is why you want to start working on projects. In Ivy's course, that is the reason why we created significant project documents which are very, very real time basis on, especially on very large complicated data sets. Then you want to participate in competition, where you can showcase your skills. That helps build up in your you know, in your resume. Okay. And then you want to make a project-based resume with social links. Social links meaning on GitHub, right? Given some kind of link where, so you've given GitHub links on your resume so that anybody can see what kind of projects you have worked on. And when you create a resume or your LinkedIn profile with projects highlighted, with project links given, then your resume and your profile becomes social in nature. Any social profiles stand out, right? You want to post your projects on your LinkedIn profile, as I said, and then start networking and then shortlist the companies. If you are available, if you have posted about your projects, right, you've become social about your skills, then automatically companies will start noticing your profile. And if they start noticing your profile, the demand is so much that you don't even have to shortlist the companies will shortlist, right? So this is what I wanted to talk about today, guys. And we will upload this video on Ivy's YouTube platform. And also on Ivy's YouTube platform, by the way, I have recently recorded one video on where I've spoken about that how can you get started, how can you start working with AWS Cloud Platform or Google Cloud Platform with basic SQL queries at least, or setting up databases there, accessing those databases on cloud. So do watch that video as well. And do explore this cloud data engineering certification course with Ivy. I'm going to give you my LinkedIn profile, guys. Feel free to reach out to me, and I'll be more than happy to answer any of your questions that you may have on this domain or any domain related to data science, data analytics, data engineering. I'll be more than happy to. So if you just Google my name, Pratik Ivy, the first link that you will get would be my LinkedIn profile, and the second link will be my Twitter profile. And these are the two places where I'm active at, and I'll be more than happy to answer any of your questions that you guys would have. And also, I'm giving you my email ID, pratik@ivproschool.com. Feel free to reach out to me, and I'll be more than happy to help with any of these questions. So guys, I'll be here for the next 3 to 5 minutes. Should you have any question, feel free to ask me now.
Hi. I've been hearing some profiles related ETL. So how is ETL different than data engineering?
Okay, ETL is one of the activities that you do as part of data engineering stream. Meaning, let me show you that document that I was showing you, right? So for example, whenever data moves from the data source to, let's say, data lake, or from data lake to, let's say, data warehouses, or from data warehouses to data marts or to presentation or a reporting software, you require E, T, and L: extract, transform, and load. And this is typically done using SQL or SQL related or SQL compliant tools. I get a point, Puneet. And ETL is one of the very, very important activity to perform as a data engineer, because remember, a data engineer is also supposed to ensure that the data is in a format that can be analyzed by the data science team. Puneet. Puneet?
Hello. Yes.
Puneet, are you there? Yeah.
Hello.
Yes, Puneet, I can hear you.
Okay, so that is not required, right? Means that things are done by managed services or something. So we don't need to learn ETL now, right?
No, you do need to learn ETL, Puneet. You strongly need to learn ETL. You got to be very, very good in ETL as a data engineer as well. ETL is to a large extent is also used extensively by data science folks, as well as is used very extensively by data engineering folks.
Okay. Got it.
Because you see, the data has to move right from one place to another. Especially if the data is there in the data warehouse, it has to go from this data warehouse to some kind of presentation layer, to some kind of reporting layer. And whenever the data has to move from one place to another, you do that using ETL.
Okay.
And any preparation, any changes to the data. I'll give you a classic example. Imagine, say, for example, one of our clients, Honeywell, right? It has 140, Honeywell is present in more than 200 countries. And ultimately, Honeywell presents its financial statement in US, as per US accounting standard, CARP, or international accounting standard. So it has to get the data from all these different countries' infrastructure, right? And then some kind of transformation has to happen, like currency conversion, forex transactions, all of that have to be done on the source data before the data can be said that, okay, this data is now ready for the Honeywell's US-based financial team, finance and accounts team, to now fetch them from the data infrastructure. So a lot of transformation has to be done beforehand. And those transformations are done by the cloud data engineers or the data engineers.
So the tool needed for ETL is somewhere in this chart itself, or some another?
In this chart itself. So see, ETL can be done if you know SQL pretty well. ETL, you don't even need any other tool. You can do using SQL. But there are a lot of these third-party tools which have come up, Teradata, Informatica. There are quite a few of them which are ETL specific tools, which allow you to work with data warehouses, on top of data warehouses as ETL tools. But they all are basically SQL complex. They end up writing SQL queries internally.
Okay.
But yeah, ETL is right over here inside the data warehouse. Whenever the data is going from the data warehouse, you end up doing ETL.
Okay.
All right. What other questions that you were discussing?
So one question just came in my mind. I don't know it's proper to ask, but as a working professional, like I'm working in a company for like 8 to 9 hours. So after that, how many time I need to invest in this data engineering?
I tell you, good question. I tell you, it takes approximately 7 to 8 months overall if you're doing only the weekend.
Okay.
Now, the general philosophy is very simple. Let's say during the week, IB's course is designed in such a way that you will spend approximately 5 to 6 hours in the courses. like in the classes, and you have to give almost 1.5 times. So let's say if you're spending 5 hours during the week into the classes, or 6 hours into the classes, then you got to spend 9 hours by yourself doing or working on projects, working on cases, working on assignments that we give to you. That means if you're doing a course, then overall commitment is anywhere between 12 to 15 hours in a week. That kind of results into 7 days, let's say, if somebody plans it out, 1.5 hour a day. But remember, you have to take out 1 hour at least every day. That 1 hour is required not to do this. If you're not able to do it, then don't do it.
Okay. Thank you, sir.
All right, guys. Thanks a lot for attending today's session, guys. Thank you for asking all the relevant questions. Please do try and explore IV's cloud data engineering program, guys. Should you have any question, as I've given you my LinkedIn ID as well as my email ID, feel free to reach out to me or reach out to IV's academic counselors, and they'll be more than happy to connect you and explain you all the details about the program as well. Remember, a couple of things, guys. It's important to learn the cloud technologies, not just the typical on-premise technologies. And also, as I said, it's important to learn and implement and work on projects, because you would be asked scenario-specific questions more than anything else. Thank you, guys. Thanks a lot, and I hope to see you again. Bye-bye. Take care. Have a good night.
Thank you, sir. Bye.
Thank you. Bye.